Hello students, this is lecture number 2 of vectors. In the lecture 1, we have discussed about the definitions of vectors and scalars, representation of the vectors by graphical and analytical method, and the different types of vectors and their definitions. In this video, we are going to learn vector algebra. That means how to add vectors using the parallelogram law of vector addition and triangle law of vector addition. This video is going to be very long, so kindly watch the full video. So the name of this chapter is vector algebra. What is vector algebra? Vector algebra is that part where we study the addition of vectors, subtraction of vectors, multiplication of vectors, which are of two types, cross product and dot product, and components of vector. Now in all this list you see that we have addition, subtraction, multiplication, but not division. Note that division of a vector by another vector is not allowed. As you can see here, vector A is in the numerator and vector B is in the denominator. But this kind of mathematical operation is invalid. It has no meaning. However, in the denominator you can have a scalar quantity, but you cannot have a vector in the denominator. Numerator can be a vector. Another thing which is not allowed is squaring or cubing a vector or taking any kind of power to the vector. However, you can take the power of magnitude of the vector. So vector cannot be squared. Let us proceed to the vector algebra. So the first thing that we study in the vector algebra is addition of vectors. Consider this very simple case. In this case there is a body of mass m and two forces. Force are vectors. Two forces, F1 is equal to 10 Newton and F2 is equal to 15 Newton. They act on a body and both the forces are acting in the same direction. So what will be the net force acting on the body? It will be obviously addition of both of these. Direct addition. You see, addition of magnitudes. We haven't put any arrow symbol also here. It is just addition of magnitudes. 10 plus 15 is equal to 25. That means when vectors are in the same direction, then we will simply add their magnitudes. Second example, suppose the forces are acting on the body in the opposite directions. Then the net force will be subtraction of the larger vector and minus the smaller. Larger minus smaller, F2 minus F1. Here also no need to put vector sign, it is just subtraction of the magnitudes. But what if the vectors act at an angle? Like this. If the vectors are acting at 90 degrees to each other, or the angle between the vectors is acute angle or obtuse angle, then neither F1 plus F2 will be the answer, nor F2 minus F1 is the answer. We will have a different formula for doing that. Let us see. So in order to add the vectors which are not in the same direction, we have two different methods which are known as parallelogram law of vector addition and triangle law of vector addition. These are two different methods of adding two vectors, and of course both of them give the same answer. Let us discuss first of all the parallelogram law. Here is the statement of the parallelogram law. If two vectors are placed along the adjacent sides of a parallelogram, see here is a parallelogram, and the two vectors are placed along the adjacent sides. So let us say the vector A is placed along one side of the parallelogram and vector B is placed along the another side of the parallelogram. And suppose the angle between them is some angle theta. Right. Now the two vectors are placed along the adjacent sides of a parallelogram. so that their tails coincide here. The tails coincide here. These are called as co-initial vectors. In the lecture number 1, we defined co-initial vectors as those vectors whose tails are at the same place. So we place them at the same point. Then the diagonal of the parallelogram. You see, in a parallelogram, there are two diagonals. One diagonal is this one and one diagonal is this one. So which diagonal will be considered as the resultant? The diagonal of the parallelogram which is contained between the vectors. That means PS, this one. This diagonal which is contained between the two vectors, not the other diagonal, this one, not QM but PS. That vector will represent the resultant or the sum of the two vectors, both in magnitude and direction. So the law says that if two vectors A and B, which contain angle theta in between them, they are placed along the adjacent sides of a parallelogram, then the diagonal of the parallelogram which is contained between these two vectors will represent the resultant, means addition of the two vectors A and B along with magnitude and direction. That means the length of this vector R will be equal to the magnitude of the addition of A and B. Let us continue. So we write the equation R is equal to A plus B. That means this vector R is equal to the addition of vector A and vector B. But note, this length or the magnitude of the resultant is not equal to the magnitude of A vector plus magnitude of B vector. Notice this equation. This is not adding the magnitude, but in fact it's a different answer. Let us find out. Let us find the magnitude and direction of the resultant R. For this, what we do that, first of all, drop a perpendicular ST on PM extended like this. So we drop a perpendicular ST on this line PM is extended MT. This is the 90-degree angle. Now notice this angle theta. How did this angle become theta? Why is angle SMT is equal to theta? Because angle theta is made by this line PQ with PM. Opposite sides of the parallelogram are equal in length. Also, opposite sides of parallelogram are parallel to each other. So these two sides are parallel. That is why this angle and this angle should be equal. They are called as corresponding angles. Another point to be noted is that because the opposite sides of a parallelogram are also equal in length, so the length of this line SM should be equal to the length of the line PQ. That means this vector B, its magnitude is B. So this and this both should have the same length as B. So the length SM must be equal to B. And the length of the vector A is written as the letter A without arrow symbol. When we write the letter without arrow symbol, it means it is the magnitude. So this much length is the magnitude. Now, what about these lengths, ST height and the MT base length of this triangle SMT? So we have constructed the triangle SMT here, and we will prove that the height is B sin theta and the base length is equal to B cos theta using trigonometry like this. So in the triangle SMT, look at the triangle SMT, sin theta, write down the sine of this angle theta. Sin theta is defined as opposite side by hypotenuse. So for this angle theta, the opposite side is this one, ST. So opposite side is ST and hypotenuse is B. The side opposite to 90-degree angle is called the hypotenuse, which is B. So from here we can say ST is equal to B into sin theta by cross multiplication. We got this value ST is equal to B sin theta. Similarly, write down the definition of cos theta. In this triangle, cos theta is equal to base upon hypotenuse. The base is MT, which MT, and hypotenuse is B. Again by cross multiplication, B into cos theta, that is equal to MT. Hence this base length is B cos theta. So we can indicate it down here. Now we can apply the Pythagoras theorem in the triangle PST. As the triangle PST is a right triangle, using the Pythagoras theorem in this triangle PST, we can write down that the square of the hypotenuse PS, you see PS is the hypotenuse, is equal to the sum of the squares of the other two sides. So PT is the base and ST is the height. Now what is the value PS? Look at here. PS is nothing but this much length, the length of the resultant. So in place of PS we can write down R. Notice here that we are writing only R without arrow. We are not putting here arrow symbol, means we are writing only the magnitude of R, the length of R. Of course, you know, we cannot square the vector, okay? We can only square its magnitude. Then PT, what is PT? Look at the figure. This much length PT is equal to A plus B cos theta. So PT is A plus B cos theta. Similarly, ST is this height B sin theta, the whole square. Now this bracket can be opened using the formula A plus B whole square. So that becomes A square plus B square cos square theta plus 2AB cos theta. And this term becomes B square sin square theta. Now notice here B square cos square theta and B square sin square theta. Take B square common from both of these. And in the bracket you will get cos square theta plus sin square theta, whose value is 1. So we know that the value of cos square theta plus sin square theta is equal to 1. So we get A square plus B square plus 2AB cos theta. So finally, by taking the square root on both sides, we find that the magnitude of this resultant R is equal to root of A square plus B square plus 2AB cos theta. So this is the formula for finding the magnitude of the resultant of the two vectors A and B. We must note here that the magnitude of the resultant is not equal to simply A plus B, simply the magnitudes of A plus B. It is A square plus B square plus 2AB under the square root. So we have to note here that vector A plus vector B is not equal to the magnitude of A plus magnitude of B. In fact, the net magnitude of resultant is given by this above formula, square root form. Similarly, how can you find out the direction of this vector PS? Let us say that this vector PS or the resultant vector R makes an angle alpha here, angle alpha with respect to the A vector. Let us find the value of this angle alpha. See, if you look at this right triangle PST, then we can say tan of alpha is equal to height upon base. So tan alpha is equal to height upon base. Height is ST and the base length is PT. This whole base length is PT is equal to A plus B cos theta. Therefore, the formula for finding the direction of the resultant vector is this one, B sin theta plus A plus B cos theta. So we must remember these two formulae. The first one is for finding the magnitude of the resultant and second one is for finding the direction of the resultant. Let us look at some solved examples. Two vectors of magnitudes 40 and 30 are perpendicular to each other. Find the magnitude and direction of resultant. So here we have two vectors A and B. Let us say A has magnitude 40 and B has magnitude 30. So R is the resultant which is drawn in this parallelogram. Because vector A and B are perpendicular, this angle here is 90 degree. So this parallelogram is actually a rectangle. And the resultant makes an angle alpha with respect to the A vector. We will find out what is the magnitude of R and what is the angle alpha. Let us proceed. So the formula for finding resultant is R is equal to root of A square plus B square plus 2AB cos theta. Substitute the values. A is equal to 40, B is equal to 30 and angle theta between the two vectors is 90 degree and the value cos 90 is 0. So this third term will become completely 0 and we will be left with only root 40 square plus 30 square. Then it will become 1600 plus 900 which is equal to 2500 and the square root of 2500 is 50. Therefore, the magnitude of the resultant is R is equal to 50. Please note here that if you simply add the magnitudes 40 plus 30, you will get 70. But the resultant has magnitude 50. So this example tells us that when we add two vectors, we don't just add their magnitudes. Because of the direction between the two, the answer comes out to be according to this formula, not simply adding A and B. Second, let us find out this angle alpha. So tan alpha can be written as, from this figure, it is a right angle here, 90 degree, this also right angle. So we can easily write down the tan alpha in this right triangle as height upon base. So this height is same as this height 30. So therefore this height is B and the base length is A. So tan alpha B by A, 30, 40, 3 by 4. This implies that angle alpha is the tan inverse of 3 by 4, which is approximately 37 degree. Example number 2. So here we have got two vectors of equal magnitudes, 10 each. Look at here, the vector A is having magnitude 10, vector B also having the same magnitude 10, are inclined at 60 degree with each other. That means the angle between the two vectors A and B is 60 degree. Find the magnitude and direction of the resultant. We have to find out what is the magnitude of this resultant and what is the direction angle alpha it makes with the vector A. Once again, using the same two formulae. First formula is the resultant R magnitude is root A square plus B square plus 2AB cos theta. Substituting the values. A is equal to 10, B is equal to 10. Here also A is 10, B 10. Then theta is 60 degree. The value of cos 60 is 1 by 2. Then this 2 will get cancelled with this 2 and 10 into 10 is 10 square. So we will get root of 10 square plus 10 square plus 10 square, which is 3 times 10 square. Taking square root will get 10 root 3. So the magnitude or the length of this resultant vector is 10 root 3. Next, let us find out what is the angle alpha, the direction. The formula derived was B sin theta divided by A plus B cos theta. Substitute the values. A and B both are value is equal to 10 and angle theta is equal to 60 degree each. Now 10 can be taken common from the denominator and it gets cancelled with the numerator. So 10 and 10 got cancelled, we get remaining this. Substitute the values now. Sin 60 is root 3 by 2 and cos 60 is 1 by 2. And 1 plus 1 by 2 is 3 by 2. Then these 2 cancel and we get root 3 by 3, which is 1 divided by root 3. So if tan alpha is 1 by root 3, then angle alpha is actually 30 degrees. Hence we have found both the answers. I hope that you are liking the video up till now. So kindly press the like button and proceed further. Next slide. Triangle law. So up till now we saw that how to add two vectors using the parallelogram law of vector addition. That was very simple and nice method. Triangle law is another method of adding two vectors. It is just a different method. The answer will be the same. Let us try to understand how triangle law is little different from the parallelogram law. Let us say we have two vectors A and B and we want to add them using the triangle law. Then what we should do is this. Take the A vector and then take the B vector and put the tail of the B vector on the head of the A vector. You have to just transpose this vector B in such a way that the tail of the vector B comes to the head of the vector A. After forming this figure, you join the vector from the tail of A to the head of B, and that is the resultant of the two vectors A and B. Now since this forms a triangular figure, this law is known as the triangle law of vector addition. So the vector joining from the tail of the first vector to the head of the second vector, that will be the resultant R, which is the vector addition of A and B. We can name this triangle, let's say PQS. So here is the statement of the triangle law. When two vectors are placed along the two sides of a triangle, like here we put it along PQ and QS, taken in order. Here taken in order means tail of the second vector is on the head of the first vector. Then the third side of the triangle represents the resultant. So this third side is the resultant of the two vectors. A very important secret of the triangle law is that the triangle law is actually hidden inside the parallelogram law. If you compare the parallelogram figure with the triangle, you will see that the diagonal of the parallelogram, the resultant vector, is dividing the parallelogram into two triangles, and the lower triangle is exactly the same figure as the triangle law of vector addition. As you saw just now that the vector A is given and the tail of the vector B is put on the head of vector A, and then the third side becomes the resultant. Now in case of parallelogram, the two vectors are placed like this and like this, so that their tails are at the same place. But we can consider the opposite side of the vector B also as the same as vector B, because this vector QS is same as the vector PT, reason being that opposite sides of the parallelogram are equal in length and opposite sides are also parallel to each other. That is why if this angle is theta, this angle should also be theta. These are corresponding angles. So that is why the vector QS is same as the B vector, because two vectors are said to be equal when they have equal magnitude and same direction. Since this line is parallel to this line, directions are same and magnitudes are also same. So combining this vector A with this vector B, we see that the diagonal is the resultant, and if we focus our attention only in this much part of triangle, we observe that this exactly looks like the triangle law of vector addition. Hence, we can say that the triangle law is actually hidden inside the parallelogram law. Only the main difference between the two laws is that in the parallelogram law, the tail of the second vector is placed on the tail of the first vector. Like here you see, the B vector tail is here and A vector tail is here, both at same place. But in the triangle law, the tail of the second vector is placed on the head of the first vector. So only the method is different. The answer they will give is the same. So that is why thus the same formula will be applicable. You see, if you again draw perpendicular from here and apply the Pythagoras theorem, we will again get the same result. And of course, triangle law should have the same formula, because ultimately we will get the same answer. So whether you use the triangle law of vector addition or the parallelogram law of vector addition, you will have the same formula and you will get the same answer. Understanding the triangle law. There is an important point that should be noted regarding the triangle law is that sometimes we are confused regarding the equation relation between the three vectors. Like here, if question says which of the following is true, means which two of them should be added to give the third as the resultant. Any one of this equation is true, remaining two are false. So how to exactly tell the answer? By looking at the directions of the three vectors. So we have a very simple technique like this. Let us imagine that a person A, see, if you see the figure, then the vector A connects to the vector B, and after that B goes up to the point C. So we can imagine as if a person is moving from A to B along this path AB and along the direction of vector AB, and then he moves along the vector BC to reach the final point C. This is what I have indicated with the arrows, because these arrows match with the direction of AB and these arrows match with the direction of BC. So finally the man starts from A and passing through B, he reaches the point C. We can say that he could have reached the point C directly by moving along the single vector AC. Therefore we can say that AB and BC together is equal to AC. Therefore AB plus BC is equal to AC is the correct relation, and the remaining two are wrong. So here is the trick, that the man first you have to imagine like that. Okay, imagine that the man first walks along AB and then along BC. So his net displacement is AB plus BC. So we should think vectors as displacements. So his net displacement is AB plus BC, which is the same as the displacement AC. So he could have achieved the same displacement by moving along the vector AC. That is why we can say that the two displacements AB plus BC is same as one single displacement AC. So we have to identify these by looking at the directions of arrow. Let us practice some more questions on the same matter. See here, three diagrams are drawn here. The vectors are represented as, this is the S vector, P vector and Q. So P, Q, S, three vectors are given. Directions are also shown here. We have to tell that which two vectors will get added to give the third as the resultant. So we can imagine like this. See the hints here. If you move along the vector CA and then you move along the vector AB, then the total displacement is same as CB. Therefore, S plus P must be equal to Q. So that is the answer. S plus P is equal to Q. In the second figure, we can identify here that P vector plus Q vector is same as the displacement S. So P plus Q is equal to S. In the third figure, we can see that BC plus CA is same as BA because this is the starting point and A is the ending point. So if the man goes from B to A, the same thing can be achieved by doing two displacements BC and CA. That is why BC plus CA will be equal to BA. Let us discuss about the maximum and minimum values of the resultant. Under what condition the resultant of the two vectors can become maximum or minimum? You know that resultant is given by the formula root of a square plus b square plus 2ab cos theta. Here we can see that the resultant is directly proportional to the cos theta. If this cos theta is maximum, then this resultant r will be maximum, and if the cos theta is minimum, then the resultant r will be minimum. So let us apply these conditions. First, r will be maximum when cos theta is maximum. It is known from mathematics that maximum value of cos theta is equal to plus 1. And this happens when the angle theta is equal to 0 degree, cos 0 is equal to plus 1. By substituting cos theta is equal to plus 1, we will get the maximum resultant r max is root a square plus b square plus 2ab. But we notice that a square plus b square plus 2ab is nothing but the expansion of a plus b whole square. So this is root of a plus b whole square, and root and square cancel, and we get final answer as a plus b. So the maximum resultant is simply a plus b, the sum of the magnitudes. Okay, maximum resultant is equal to the sum of magnitudes, and this happens when the angle theta is 0 degree. That means theta is equal to 0 degree means both the vectors are in the same direction. Then we will obtain the maximum resultant is equal to a plus b. Now coming to the minimum condition. Resultant will be minimum when the cos theta is minimum. And what is the minimum value of cos theta? It is equal to minus 1. This happens at what angle? When the angle is equal to 180 degrees. So we can substitute cos theta is equal to minus 1. So we will get minimum resultant is equal to root a square plus b square minus 2ab. Then we realize that this expression is the expansion of a minus b whole square. So root of a minus b whole square. By taking square root, we will get r minimum is equal to a minus b. Now here we have put a mod here because sometimes this difference can be negative value. Say a is smaller than b, then a minus b will be negative. That is why we are putting the mod here. If a is greater than b, then there is no problem. So this is obtained when the angle theta is 180 degrees. So the minimum resultant is equal to the difference of the magnitudes. And this happens when angle theta is 180 degrees. That means the vectors are opposite to each other. So the final summary is that maximum resultant of two vectors is equal to the sum of the magnitudes, and the minimum resultant is the difference of the magnitudes. Let us solve two questions based on this concept. First question is that find the maximum and minimum resultant of two vectors of magnitudes 10 and 20 units. So you can see that formula we know r max is equal to a plus b. Maximum resultant is a plus b. So that is 10 plus 20 is equal to 30. And the minimum resultant is a minus b. That is, we take bigger one first. Okay, so 20 minus 10 is equal to 10. That's so simple question. Let's go to the next question. If the maximum resultant of two vectors is 20, that means this is a plus b, and their minimum resultant is 6, this is a minus b. Then find the magnitudes of the two vectors. So from the question what we understand that r max is a plus b is equal to 20, and r minimum, that is a minus b, is equal to 6. Then after that, if we add above two equations, so from here we have to find the values of a and b. So we have got two linear equations in two variables or two unknowns. So we will add both the equation to cancel the b with each other. So adding the above two equations, write the two equations first of all, one below the other, and draw a line, then add both the equations. So b minus b cancel, and a plus a, 2a is equal to 20 plus 6, 26. Therefore a is equal to 13, first answer. Then take the first equation, that is a plus b equal to 20, substitute the value of a is 13 and b is equal to 20 minus 13 is equal to 7. So these are the two values. We can cross check once again that the maximum resultant is 20, add both of these. 13 plus 7 is 20, yes. Is the minimum, that minimum resultant is 6, that means difference is 6, yes. 37 minus 7 is 6. 13 minus 7 is 6, that's true. Once again, if you have liked it till this point, please press the like button and continue to next part. Now we are going to study some special cases of vector addition. First special case is when both the vectors are having equal magnitude and they are at right angles, means the angle between the vectors is 90 degree. So suppose that this is the first vector a whose magnitude is x, and this is the second vector b, that magnitude is also equal to x. So this is a special case where both vectors have the equal magnitude and the angle between them 90 degree. Then the resultant will be root 2 times of x, and the angle made by the resultant with a vector will be 45 degrees. So the remaining angle is also 45 degrees. Let us prove it by simple calculation. So first of all, this parallelogram is actually a square shape because these two sides are equal, and in a parallelogram opposite sides are also equal. So this is x, so this also x. This is x, this also x, and angle 90 degrees, so hence it is a square. Using the formula for the resultant, resultant is root a square plus b square. Now what happened to this 2ab cos theta, because theta is 90 degrees, so cos 90 is 0, so that part becomes 0. So the net resultant is root a square plus b square, and substituting the value a and b both are equal to x only, so therefore we'll get root 2 times of x. So the resultant is root 2x. And what about the angle? So tan alpha is equal to height upon base. Height is equal to x, base length also equal to x, so x by equal to 1. Therefore angle alpha is equal to 45 degrees. Here we also observe that in a square the diagonal bisects the angle between the adjacent sides. That is why this 90 degree was bisected by the resultant as 45 degree and 45 degree. This happens only when the two vectors are equal in magnitude and the angle between them 90 degrees. Let's go to second special case. In the second special case, the vectors of unequal magnitude, they are at right angles. So look at here, the parallelogram will be forming a rectangle figure. The parallelogram is a rectangle. So as you can see that one side is equal to a, other side is b. They are unequal sides, but the angle between the two vectors is 90 degree, theta is 90 degree. So the resultant using Pythagoras theorem directly will be root a square plus b square, and this angle alpha can be written as tan alpha is equal to height b upon base a. That's so simple. So please note here that in a rectangle the diagonal does not bisect the angle. Yes, this angle alpha, but this angle is not alpha. This is a different angle. The diagonal does not bisect the angle between the adjacent sides. It happens only in a square or rhombus. So only if the magnitudes of a and b are equal, then only the resultant or the diagonal will bisect this angle between the two vectors. Third special case, equal magnitude vectors and theta is 60 degrees. See, 60 degrees is a very special angle, so we must be ready for the answer. If suppose the two vectors are having equal magnitude, let us say a is equal to x, b also equal to x, same magnitude, and the angle between the two vectors is equal to 60 degree, then in this case the resultant will be root 3x, and it will also bisect the angle between the two vectors. 60 will be bisected at 30 and 30. Let us prove it. So first of all, this parallelogram is a rhombus. Then using the standard formula, r is equal to root a square plus b square plus 2ab cos theta, and substitute that value that both of the vectors have same magnitude, so x square plus 2ab means 2 into x into cos of 60 degrees angle, which is 1 by 2. So 2 to cancel, and we get x square plus x square plus x square, which is root 3x square, that is root 3x. Hence prove that the resultant will be root 3x. This special case must be memorized, must be remembered. Then what about this angle alpha? So using the formula tan alpha is equal to b sin theta upon a plus b cos theta, substituting the values as a and b both are having same magnitude x, write down x here, and theta is 60 degree. So x will get cancelled and we get this. Now we substitute the values of sin 60 as root 3 by 2 and 1 plus cos 60 means 1 plus 1 by 2, which is 3 by 2. 2 cancels and we get root 3 by 3. Final answer is 1 by root 3. Therefore, angle alpha is equal to 30 degrees. So you can see that the resultant has bisected the angle as 30 and 30. So we are observing that in many cases the resultant is bisecting the angle. When does it happen? The resultant bisects the angle between the vectors. Because in a rhombus, because the figure is a rhombus, that's why in a rhombus the diagonal bisects the angle between the adjacent sides. So this is the property of a rhombus or a square. Fourth special case, if the vectors are having equal magnitude and the angle between them is 120 degrees. So this is the angle between the two vectors. This is vector A and this is vector B, both having the same magnitude x, angle between them 120. Then it is an interesting case that the resultant will have also the same magnitude x as that of the both the vectors, and the resultant will also bisect the angle between the two vectors. So 120 is bisected as 60 and 60. Let us prove it. So first of all, this parallelogram is a rhombus. Now standard formula is resultant r is equal to root a square plus b square plus 2ab cos theta. Substituting the values. So a, b both are same, x square plus 2 into x into, and cos of 120 degree is minus 1 by 2. 2 cancels and we are getting x square minus x square, these two cancel and only x square is remaining in the square root, and so the final answer is equal to x. So we have proved that the magnitude of the resultant is equal to the magnitude of both the vectors when the angle between them is 120 degree. So here also we observe that the resultant bisects the angle between the vectors because in a rhombus the diagonal bisects the angle between the adjacent sides. Fifth special case, each equal magnitude vectors for any general angle theta. Okay, so we have seen different angles like 60 degree, 120 degree, 90 degrees. Let us find out the answer for a general angle theta and both vectors having the same magnitude x and x. So here also we will see that the resultant will bisect the angle theta as theta by 2 and theta by 2 because this is a rhombus figure and in rhombus the diagonal will bisect the angle. So parallelogram is a rhombus. So now we apply the parallelogram law, root a square plus b square plus 2ab cos theta, substitute the values. So a and b both are equal to x, but theta is general angle, so just keep it as cos theta only. Now adding x square plus x square become 2x square. So both places we are having 2x square, take the 2x square common. And first of all, what you do that you divide by 2 here and then you can take 2x common out of that. So we are getting root 1 plus cos theta divided by 2. From the trigonometry we know that this is just written in another way. Actually we should have taken the 2x square common and divide by 2, and so this step is not useful. So from here only you take 2x square common and divide by 2. So 1 more 2 you can put here, okay, so 4x square. So that you can take the square root of 4x square as 2x outside. I think steps got mixed up here. Okay. So finally, after solving this, you will get r is equal to 2x cos theta by 2y because this factor here, I think steps are in the opposite manner. Firstly this, then this, and then this. Actually from this step, we are taking 2x square common. So by taking 2x square common, you get 1 plus cos theta. Then after that, you multiply here 2 and here divide by 2. So that you can take the square root of 4x square outside as 2x, and the remaining thing in the square root is 1 plus cos theta by 2. And it is a trigonometric formula that root 1 plus cos theta by 2 is nothing but cos of theta by 2. So therefore we get the resultant r as 2x into cos theta by 2. And regarding the angle, we can prove that using this formula, we can easily prove that the resultant will bisect the angle. Substituting the values here, a, b both are equal to x. Then cancel x, we get sin theta upon 1 plus cos theta. Then sin theta can be written as the 2 times of sin theta by 2 into cos theta by 2. And 1 plus cos theta can be written as the 2 cos square theta by 2. From here also you can see this is equal to cos theta by 2. So 1 plus cos theta is nothing but 2 times of cos square theta by 2. And the sin theta using the formula for sin 2 theta. You know, sin 2 theta is 2 sin theta cos theta. So therefore sin theta can be written as 2 sin theta by 2 cos theta by 2. So cancel 2 and cos theta by 2 also cancel from here. And we get sin theta by 2 divided by cos theta by 2, which is equal to tan theta by 2. So tan alpha is tan theta by 2. That means angle alpha is equal to theta by 2. So hence proved here that this angle is equal to theta by 2. So the resultant makes angle theta by 2. Hence finally it is proved that whenever you are having the vectors of equal magnitude, the resultant will bisect the angle between them. So here is the final summary of all the 5 cases that we have discussed. In the first case, angle between the two vectors is 90 degree and vectors have equal magnitude. Second case, vectors are having unequal magnitude but angle is 90 degree. Third case, the vectors have equal magnitude at angle between them 60 degree. Here vectors have equal magnitude, angle is 120 degree. Here vectors have equal magnitude, angle is theta. So in all the cases except this one, vectors have same magnitude. So it is better to memorize these results. These are very easy to remember. And the most important fact to note is that when vectors have equal magnitude, their resultant bisects the angle between them. So this is your formula chart. If you memorize this, because 90% questions in the exam that are asked will be either angle between them 90 degree or 60 degree or 120 degree or any general angle theta with equal magnitude. So if you memorize this formula, then it will be easier to get the answer quickly. So the remaining part will be continued in the next lecture. Up till now we have completed the triangle law. So in the lecture number 3, we discussed about the subtraction of vectors and remaining other parts. Thank you for watching the video, and definitely don't forget to press the like button, and also you can write your comments, subscribe also, and share with your friends. Thank you.